Hello everyone! In this lecture, we will discuss about characters, strings, and ranges. So first, I want to show you what is the difference between characters and strings, because there is a very important distinction. So let's define C as a character. So to set C equal to the character, for example, A, we will use single quotes. And that's the most important thing here. A character will be defined using a single quote. If you question about the size of the character, you can always ask size of C, and then you will realize that a character has a size of 4 bytes. So it has it's 32 bits. It has a small size. So one can concatenate several characters using the multiplication sign. So if I make C times C and return it into the variable D, we will obtain AA, because A is actually the value of the character contained in the variable C. Remember, C is equal to A, just for the confusion. Now you should see a big difference, because C is equal to A has one quote, so the type is a character, ASCII Unicode. But D, which is composed of 2 characters, has now a double quote. So we have A surrounded by double quote. So what's the type of D? The type of D is actually a string. And we have used the string earlier in the code by typing hello world, for example. So let's do it again. Let's type E is equal to hello world. And now we use the double quote. That's actually a string. So the string is defined using the double quote. Hello world is a string, and it's composed of concatenated characters. Concatenated means they are put next to each other. How to compose a string? You can compose it using different types. So in this example now, we're going to construct a string, which we will call rock. And this string rock receives the word granite. So we use the double quote. That's the first thing. So we've defined a rock as the word granite. And then we will compose the string using this information, using the basic rock string. And we will append or concatenate different pieces of information. So now there is a function here, string, that will allow you to generate a string composed of different types. So the first argument can be rock, which is a string, granite. And here in the second argument, I hard-coded another string, double quote, underscore, sample, underscore. Then the third argument, I put a character. This is a hash symbol. You see the single quote. And in the last argument, I've put an integer, number 1. You could have an arbitrary number of argument in the function string. And what this returns is this composed string. So the result is a string, and it will contain granite, the information contained within rock, and it will contain underscore sample underscore, then the hash symbol, and 1. So that's one example of string composition. Another thing that can be done is string interpolation, and this is when you basically see the dollar sign. So here we are doing a very similar example. We've defined a variable rock, but now the number 1 is assigned to the variable number. So number is equal to 1, and we construct A as double quote dollar rock. So what dollar rock is going to do is going to substitute rock by the value, which is a string granite. Sample will be just a string, and dollar number will substitute number by its value 1. So the result is granite sample 1. So these are two examples of how to construct strings, and they will come useful at some point because the strings are used to generate file names, variable names. They're used to label the figures or the axis of the figures, and to make, for example, a database, you will need to generate strings. So it's very important to know how to deal with strings. Another important type that I want to mention is the Boolean type. So the Boolean type is basically true or false. It has two values. So let's define a Boolean. A is equal to true. So the value is true. So take care that here, true is not a string. It's directly, it's actually a value. There is no double quote around true. The type of A is bool in Julia. And the Booleans are very useful because in practice they can be used to set a condition. So let's make the exercise. Now A is equal to 100. And now we are going to check. So A is an integer, it's equal to 100. Is A smaller than 10? Obviously, 100 is not smaller than 10. So what this operation returns, it is a Boolean, and the value is set to false. Let's make another test. Is A larger than 10? Obviously, 100 is larger than 10, so this operation will return a Boolean with the value true. So this will be very important further in the lecture, because the Booleans and test will be used to make decisions. So we will discuss if statements and while statements, which requires conditions, in the next lecture, and you will see it will be a practical application of Booleans. So now, one thing which we have used earlier in the lecture is the line range. We actually use it quite a lot, and I should give you a few words about what is a line range. So in the first exercise, we plotted the line by generated x as a line range from 0 to 1 with 100 points, and we plotted x as a function of x, and this makes this figure. So if you check the type of x, it's a line range, float 64 and int 64. So float 64s are basically the minimum and maximum value, and the int 64 is the number of steps. Then a line range is it applies to a regular sequence of numbers. So for example, 1, 2, 3, 4, 5. It would not apply to an irregular sequence of number like 1.1, 2.3, 2.9, 4.2, 5.4, because the step between the numbers here varies all the time. So you cannot construct you can only use ranges for regular steps. The question is, in last lecture we discussed arrays, and you may wonder what is the difference between a range and an array. So The range only works with regular sequences of number which have a constant step, but you can access it the same way as an array. So if you type x of 1, it will be 0, and x of n, it will be 1. And you can type anything between 1 and 100, the number of steps, and it will return a value. It can be accessed as an array of 100 floats here. So it's very similar to an array in a way, but if you check the size, it's only 32 bytes. So it's a very tiny object. So yes, it's different than an array. If you would make an array of 100 zeros, floating type here, the size would be 800. And if you make it, let's make a range with 10,000 elements. So we construct the range, same range as before, but we put 10,000 elements. And still, the size of x is 32 bytes. In contrast with an array of 10,000 floats, which would have a size of 80,000 bytes. So there is a big difference between a range and a vector. A range can only apply to regular sequence of numbers which have a constant spacing. And the array is more flexible in a way, but it takes much more space because we're storing all the data. Basically, in the range, the only data which is stored will be the minimum value, the maximum value, and the number of steps. All intermediate values are computed on the fly, they are never stored. Another type which is important is the unit range. So the unit range, those who are familiar with MATLAB, I guess you've seen this notation quite a lot. So if we make a is equal 1:100, it will generate a sequence of number with a step of 1, starting from 1 and going to 100. So in Julia it will look like 1:100. So it will generate 1, 2, 3, 4, 5, this type of sequence until 100. If you find this key on your keyboard, you're lucky. So it's a unit range. If you check the type, this is called unit range int 64. It's very light. Here it's only 16. So to define this range, we only need two integers, 1 and 100. But you can also control the step size. So the default is set to 1, but you can also introduce now another integer number in the middle, which is the step. So if you make 1:2:100, then the range will go from 1 to, at best, 100 with a step of 2. But here's the result. It can only go to 99 because we are making a step of 2, and 100 is not included in the sequence of number. So it may truncate your sequence of number here. So minimum value, maximum value, and step. You can also go backward if you set a negative step. So we do the same here. We go from 100 with a step of -2 until 1. And again, you see that it cannot reach number 1 because it's not included in the sequence of numbers. So when is this useful? So the step will be useful to define a range of indices in a loop, which we discuss in the next lecture. So you've seen this already. We've been using loops. If you make a loop for I going from 1 to 10, this is actually a range. So if you copy this example, you will see that it will print numbers going from 1 to 10. So there we can repeat some action, like printing. The unit range is also useful for slicing an array. So slicing is basically extracting a portion of an array. So if we define an array, now A receives these values, and we want to access, for example, the first 3 elements of A, we can do A, square brackets, 1:3. And this returns 1 to 1. the three first elements. This 1 to 3 is a unit range. If you want to access the last three values, then a bracket and -2 colon end. And then you use a unit range, which will return you the last three values of the array, 23, 90, and 2. So this lecture, we've learned about the distinction between characters and strings. We discussed about Booleans. And we made a little overview of linear ranges and unit ranges. So these are common types that are used in many programming languages for constructing loops and slicing arrays. Thanks for your attention.